Okay, hello everyone. Welcome to the online lecture portion of Global Health. As promised, we're going to go over some RStudio tutorial work. I know I linked the EpiR handbook walkthrough, which is a very good resource. It's very good to show you one kind of manner of doing things using a couple different packages or a couple different commands. I didn't find it all inclusive. And even with this tutorial, it won't be all inclusive of the way you can do something in RStudio. That's kind of one of the benefits of something that is open source. The reason I say that is there's always kind of new packages, new functions, and so on that are coming out all the time. So that said, even after going through all of this, as I've tried to make it as applicable to what you kind of see in the workforce right now, by the time you get to the workforce, there's probably going to be little extra additives that have been introduced. For example, in one of the environments that I worked, they actually made it their own kind of package. So I had to install kind of the public health library that they used, which was really cool. It had some unique functions. If that's the path you want to go down, anyone can write their own functions. It's really neat. I never got into it, but just something to think about. Okay, so like I said, I'm gonna kind of go over some of the things that I've done, kind of the methodology that I prefer, and then just giving you kind of that option. So today, what I'm going to do, I downloaded some COVID-19 data from Our World in Data, which is one of the databases that we talked about in class. I'll kind of go over that as well as kind of what I did with it and the process to get something relatively not necessarily too basic, but just a basic graph outputted. Now, I hope everyone got RStudio downloaded onto their machine. If you didn't, come and see me and we can figure it out. You do need kind of the base R program, and then you need RStudio itself. So think of it as though kind of the base R is like the brain and RStudio is the body, right? So the brain contains all the intention of what to do. It does all the actual work, and then the body gives that kind of external applicability, right? So it's RStudio that's going to put out the graphs, but base R is kind of the gears that are turning behind the scenes. Okay, so let's dive into it. So first thing I got to do is I have to bring in all of the packages I want to use. Now, before I can bring them in, as you see them here, I would technically have to install them. Now, to install, all I have to do for that is I am going to put in the code install.packages. And then that pops up. I have my brackets, and then I put the package that I'm looking for inside. So let's say I want to download tidyr. There it is in quotations. I would run this line, and then it would install everything to do with that package. Now, I already have all this stuff installed, so I'm not going to go through and install it again. However, not that long ago, I ended up using a new computer. So the easiest thing that I did is I actually have a file. So I can show you here. If I go back, I have a file that I took from, it's kind of, I have like my own little library of RStudio files. I took this file, I brought it to this computer, uploaded it, and it contains all of these libraries just in this code here. All I have to do is I'm going to, there's a replace function. Let's see if I can find it off the top of my head. I believe it is replace and find here. So I would use that, and I can replace all of that with install.packages. And then I would click all, and everything would change to install packages. And then I can run and install everything, which will take a while, but nonetheless, it would work. So the way we run code in R, the easiest way is to highlight everything you want to run, and then you just hit run at the top. Okay, that is kind of the surefire way to upload everything or run everything that you've coded for without anything crashing. Now, I will give one recommendation, and that recommendation is if you have kind of your whole list of code typed out, these can get really lengthy. You don't want to run them all at the same time. So even in this code here, I have about 120 lines of code, right? It's actually a relatively small kind of project. I still wouldn't want to run all of that at once. And the reason for this is R can be buggy and it can glitch out and it can cause errors. As well as if I do get an error message that pops up in my code, I want to be able to locate it relatively quickly. So that's just kind of one way to identify where the issue is going on, because it does kind of compound. If I do have an error in one line of code, I can see an error pop up for a subsequent line of code. It won't be your typical red line error. It'll come up as something else. Those get really frustrating to deal with. Okay, so the other thing to do with errors. So I just want to make the disclaimer that anytime you use RStudio and you code, chances are there's going to be an error somewhere. They can get really frustrating. Don't get discouraged. Like I said in class, there's things called Stack Overflow, which is a forum that can help guide you if you're having issues. Sometimes it's just a case of restarting RStudio, which has happened to me many times. It actually happened to me at least once while I was writing up this project where I had to restart RStudio to get it to work. Okay, so let's bring our libraries in here. So I've highlighted them, I hit run. So one other thing you'll notice is you'll get conflicts that come up here. And what it's showing me here is it's called masking. Basically, all that means is that a command from one library is masking. So it's being redundant. It's doing the same thing as a command from a different library. And this is just going to tell me which one is kind of doing what. So for example, if I look at my lines, this one here, lubridate, and the command date with brackets is masking base date with brackets. Not a big deal. It's the same command, but they might do different things at times. So just be aware of kind of what's masking what and what's doing what. Okay. Now, the other thing you'll notice is when I ran the code, this little arrow disappeared. That disappeared to tell me that the computer, the RStudio, is still thinking. Let the arrow show up again before you run anything else. The reason for this is if you try to run more while it's already thinking about something, most likely you're going to cause an error or a crash. Okay. Sometimes you have to be patient. I have run code, which has taken 5, 10, 15 minutes to run. It all depends on the data set you're using and how extensive the code is and what you're trying to get it to do. Okay. All right. So my libraries are ported in. Next thing I have to do is I have to do what's called set my work directory. Basically what this does is it's going to set, it's going to tell RStudio where to look for the folder or for the files that I'm going to call into the program. So like I said, I downloaded stuff from our world and data. So I actually made its own little folder. So if I pull up the folder here, this is kind of my RStudio projects. So I have my library uploading, I have my R world and data, and then I have a fitness code that I've run for stuff in the past. So I go into the R world and data folder. I see my data is here, and then I have the code for the project itself. Okay, so the population data, I'm not going to lie, I did that myself. I just did a quick Google search for this project and pulled population from a couple countries because we're going to do an incidence calculation. But I also have the data that I pulled here, which is in a CSV file. Now, this is important because when I call in the data, I have to know kind of what the extension is, right? .csv or .xlsx. That is important. Now, to set my working directory, I'm going to click at the top here, and you see how the pathway comes in. I'm going to Control-C to copy it. I'm going to go back to RStudio, and I'm just going to type in the code setwd with brackets, and then Control-V, and that's going to put in the file path. Don't forget the quotations. That's going to tell it to look for something very explicit. Now, one thing you'll notice is if you look at line 31, which we just added, the slashes in the file pathway, they're going the wrong way. This is important because if I run this, it shouldn't work. Right? So let's just run this one. And I get an error. Used without hex digits. So it's going to tell me something's wrong. Now, right away, I'm going to check everything. I'm going to make sure that my function is right. Yep, it looks good. I have my quotations, but I noticed that the slashes are going the wrong way. So I just correct that. I'm going to use line 30. I don't know why it's designed this way, but it's just one of the designs of RStudio. So now when I run this one, I get the arrow, which tells me that it's good to go. I have no errors, so my working directory is set. Now we can bring in my data. So for this, I typically use the function read.csv or read_excel, depending what file type I'm bringing in. I will be completely honest with you. I have never brought in a Word document. I've created Word documents through RStudio, but I've never brought the Word document into R to do any sort of analysis. Typically, I will port everything to Excel or so an Excel file, I should say, or a .csv. It's just much easier to work with. So I'm going to call in these two data sets, and it's going to take a little bit of time. Depending on how big the data set is, determines how long it takes to bring in. So you'll notice that the R world and data took a little bit longer than population. That's because the R world and data set, it has over 251,000 observations or data points. Meanwhile, population has 1. So if I open population, I have 1 observation for 5 variables. 1, 2, 3, 4, 5. Right? Pretty straightforward. Now, when I look at the R world and data stuff, there is a lot, right? So this is COVID data for every country that reports COVID, I should say, since the start of the pandemic. So lots of observations. That will happen sometimes where the data will just disappear. It doesn't mean you lost data, it's taking time to think. So either way, when that happens, I'll just close it and I'll reopen it and it should pop back up. Now we don't need all this data. So what's the best thing to do? We are going to clean the data now. Now, when I clean the data, I'm not really worrying with this data about any kind of duplicate values. I'm assuming that's been taken care of for me. If it was my own data set, I would probably be worried about duplicates and I'm going to say misentries, right? Some sort of error when it was inputted. That has to all be done. There's a way to do duplicates in RStudio, but not for manual typing errors. That's going to have to be something that you look through manually. So the other thing, when I clean the data, I'm going to make it so that it's in a format. It's going to contain everything I need to use that I want to use, but I'm also going to clean it up so that there's also no NAs within the data set, because that can kind of be a pain when we're doing any form of calculation. So what I've decided to include, because I think I might need it later on, I'm going to take the location, which again, I'm going to look at the data set and see what variables I want to take. So I'm going to take location, date, the total number of cases, the new cases that pop up, total deaths, new deaths, and median age of everything associated with that data set. The other thing I'm going to suggest you get into the habit of doing, anytime you're dealing with a date, always kind of modify it with this command. So I take the variable name, which is date. I'm going to use the function as.date, and then I'm going to put the variable name back in it. Basically, what I'm doing is I'm creating, quote unquote, creating a new date variable with the same name as the old one, and I'm making sure that it's in a date format. The reason this is important, if I go back here, is because the date comes up as a numerical value. Okay. Now, the most frustrating thing as an epidemiologist was trying to work with these values and RStudio thinking that they were numeric and not dates. So I just get rid of that problem right away. The other thing I should mention is anytime I do something with data, I'm always going to make what's called a new data frame. So there's going to be something new that pops up in my environment pane. The reason for this is I can always backtrack and I can call up previous data frames to start from. So I don't have to start from scratch every time. And this is going to come in handy later on. And I'll bring it up again when we get there. So I'm going to run this. It's going to take a little bit of time because, like I said, there's 251,000 observations. And so now that it's done, what you can see is I still have that 251,000 observations, but instead of 67 variables, I'm down to 7 variables. Okay. So when I look at this now, you'll see it's reduced, right? I have all the values that I think I'm going to need, or I should say all the variables. Now, my next problem, which I mentioned earlier, is these NA values, right? They're going to be an issue when I try and calculate averages or do any sort of arithmetic. So what I'm going to do is I'm going to use this command here, which I don't think is in Epi-R handbook on line 41. What this basically is doing is I'm taking my data frame that I'm working with, and I'm going to replace all the NAs with a 0. Okay, so when I run this and I open it again, now all the NAs are 0. So next up, I'm going to turn to my population data. Now, one of the things I know I'm going to have to do is I'm going to have to combine these data sets. Okay, so to do any sort of calculation, because if I look at my my clean data set, I don't have any population value here, right? I had population density in the raw data, but not in the clean. So that wasn't good enough. I had to get population data. Now, when I go to merge these two data sets, this isn't going to work because of the layout. I actually need the country in the column, or sorry, I should say the row. They need to be vertical instead of horizontal. Now, how I do this is I'm going to pivot data. The Epi handbook or Epi-R handbook actually has a great tutorial for this. Basically, I just took the code to pivot longer. So taking the horizontal data and making it vertical, straight from there, just replacing with the columns. Basically, what I do is I use the command pivot longer. I use the column numbers that I want to extend. And then what I'm going to do from there is I have to rename the columns. So I'm going to take this out for a second. So I should mention that if I want to comment something out or I don't want code to run, I just add a hashtag in front of it. And anything that's green is going to stop it. Or it's not going to run. It's going to be invisible. So let me call this in to begin with. So pop is my new data frame. I've pivoted it to be longer now. And when I open it up, now I have everything just the way I want it. However, I still have another problem, because when I go to merge the data frames, RStudio is going to look for columns that are named the same, or at least one of the columns named the same, so that it can align the data as it's needed. Now, my columns are named name and value. If I go to my clean data set, I don't have anything named name or value. But what I do have is for my countries, it's named location. So what I'm going to do, I'm going to rename the name column as location. And then just so I don't get confused later, my value column is going to be called population. So I'm going to take out that hashtag and run everything right away. Now when I look, I have location and population. So everything as needed. Now I can do kind of what I need to do to merge these two together. One thing I should say is that in order to chain your lines of code together, I did kind of skip over this really quickly. There are some things I kind of take for granted of let's say the fundamentals that I might come back to. So I do apologize if it's a little confusing. So this percent, I call them arrows, but percent arrow percent, that just tells RStudio to look at the next line for another instruction. Okay, so whenever I have multi-lined kind of chunks, I have to use that indicator to tell RStudio to keep looking at the next line. Okay, so now we have everything cleaned and ready to go. Now I have to start to fine tune what I'm trying to do. What I've decided to do here is I've decided that, let's say my supervisors come to me and asked, okay, we want to compare Canada's COVID numbers with other countries to see how it might be, to see how we're doing, to see what's coming down the pipeline. In this kind of demonstration, I wanted to pick something that aligned with what we talked about in lecture 2 when we were comparing countries and the COVID-19 response. So for that reason, let's say I get my assignment and I have to look at Canada, the United States, Chad, Sweden, and Denmark. So I'm going to create a new data frame. We're going to call it OID_W1. And I'm taking it from the clean database that I just worked on. Now, another thing that I do is I always make sure that the variable that I'm looking at is in the correct kind of type that I need it to be. So in this case, line 54, all I'm doing is I'm making sure that the location variable is in a text format. It's a character variable. This is typically unnecessary. You probably don't need to do this. This is just kind of a little bit of RStudio paranoia. So the next thing I'm going to do is I want to take my clean data frame and I want to limit it to only entries that are coming from Canada, United States, Sweden, Denmark, and Chad. So what I do is I filter out the data frame. I use the command filter. I select the variable or the column that I'm filtering from. And then I use C to let it know that it's all the text. And then I type all my variable names as follows. Okay. So now when I run, I get my new data frame, which is W1. I click and it has, whereas before it started with Afghanistan, now it starts with Canada, and it's going to have, there's going to be a lot of entries here, so I won't scroll the whole way down, but it's going to have Canada, and then it should be United States, right? So I've gone from 251,000 observations down to 5,000 and change. Okay, so let me just close some of these so we don't get bogged down. Okay, so now I have a clean data set with just data from those 5 countries. Now what I want to do is I want to merge my kind of my selected data frame with the population. Okay, so this line here, I'm going to take away, again, the continuation line first, so I can just demonstrate, I'm going to demonstrate what this does. So basically, I use the command merge. Now, the reason I do this is I used to use the commands that are in the EPR handbook, the left join, right join. I kind of fell out of favor with that because I ran into a lot of issues as I got into bigger data frames. So now I use merge, and I just merge by a certain column. I find that's the easiest way to do it. So what's this saying? Merge OID W1 with pop. So those are my 2 data frames, and then the by command, and then the column I'm trying to combine for. So I'm going to run this. Now W2. Now I have my population, and my population will, oh, that's the other thing. If I left join, I might only get population for one of my Canada entries. By merging, I get it for all of them. So as you see, I have the Canadian population, and if I scroll down to the US, the population is different, right? So I know everything corresponds. And I'll do those kind of spot checks as I go to make sure that everything is aligning. Now this next line, line 59, so just like we selected, if I scroll up just like we selected the variables we were interested in when I first brought in kind of the data set and got it to 7 variables. Sometimes it's easier to what's called kind of the inverse. I'm deselecting variables. So it doesn't make sense for me to, well, this one's a little bit of a poor example, but I could have easily selected the 4 variables that I wanted, or I should say the 5 variables I wanted in here. But it's much easier just to quote unquote deselect the ones I don't want. And the only difference here is I'm going to add negative C for this. And what that means is I'm negatively selecting out everything in the brackets. So if I look at W2, right now there's 8 variables. When I run this again, I get down to 5, right? And that has everything I need, total cases, new cases, population. Now I can start looking at, okay, now let's calculate some incident rates. Okay, so I now want to calculate my incidence, but it gets to the point where as time goes on, I might not be interested in the incident rates from 2020 or even 2021. So what I'm going to do is I'm going to filter out by the date. So I'm only interested in 2022 incident rates, right? I'm looking at daily incident rates in these examples. Okay, so what I do for that, it's the same process as filtering by country. So what I'm going to do is I'm going to use my filter function and I select the bounds by saying date greater than or equal to January 1st of 2022. And I also want to make sure that there's nothing that goes past December 31st. So I'm just going to double check this. I have a feeling. Yes. Okay. So everything going forward from January 1st and everything before December 31st. So when I look at my OID incidents, you can see I've gone down by about 3,000 observations. And we can see here, I've got January 1st. I can scroll down and do a quick spot check, and I have the 31st. So I have all the data that I need, and total cases adds up as I go. Okay, so now that I know that that's correct, because sometimes I find with RStudio, it's always best to check if you're unsure, and it only takes 2 seconds. Next, I want to create a new variable for incidents, right? So my equation for incidents is the number of new cases divided by the population at risk, and then times kind of call it the equalizer so that we can compare, right? So by 100,000. Now, my population at risk for something like this, just to data constraints, is going to be the entire population, right? I'm not going to try and take out who's been infected before, also because there were different variants circulating as well. So technically everyone's at risk. So I use the mutate function to create that new variable, select everything and run. And when I look, I have my incidence, and this is per 100,000. I can put that in the title. And the way I would do that is I would use what looks like a single dash for the quotations, but it's not. It's above the tab button on your keyboard. And then I can write my entire variable name that I want, and I use that slash again. And this lets me use spaces, I should say. If I do this without that single dash, it will give me an error because RStudio is not going to recognize the space. Now, if I run that again and I look, instance per 100,000. So that's how I get there. Now, if I go back here, you'll notice that I have way too many decimal spots, right? It's a little bit ridiculous. So what I have to do is I'm going to round that value. I'm going to round that value by I'm going to make another variable. And now I don't have to do another variable if I don't want to. I did this just to show you guys. So I make my other variable rounded is the name of it. If I didn't want to make another variable, I can either put it in the same line up here, which I believe I do later on, or I would just change the name of my new variable to coincide with the incident variable beforehand. Now I do have to change this back to what it was before because everything I do after this, specifically the rounding, calls on that variable to do it. So I have my rounded code. I'm going to round to 2 decimal places, right? 2 spots past the decimal point of the variable incidence. I run this again. I check it. I have my 2 decimal points. So it's nothing insane, right? And like I said, in a real world example, I would probably make these the same name so that it collapses into one column, or I would just round the incidence so I didn't have an extra column, right? Kind of one thing with RStudio is the simpler the better. So if I add data that I don't need or I leave it around, it's just another thing that can confuse me. So I want to take that away. Okay, so that's calculating incidence, the daily incidence over the course of that full year, one for every day. Now, let's say I want to look at the weekly total cases and the weekly incident rates. Now, this gets a little bit messy, and I'll show you why. But generally, it does take a little bit of finesse. There is a way to narrow it down and select only certain dates. But I left that out of this tutorial as I wanted to keep it kind of fundamental. Basically, what I want to show you here is this tally function. Now, what I do is I have my filtered dates, which realistically I probably, oh no, I didn't need to do it. I could call in the incidence data frame again, but again, it would make it confusing because I'd have multiple things called incidents. So what I'm going to do is I'm just going to call in the old data set and then perform the filter function. So I call in the old W2 data set. I filter it for the same 2020. And then I'm going to make a variable that tells me what week corresponds where. Now, this is where this can change depending on what you want to do, because there are ways, like I said, to filter it out in certain ways so that you don't have 7 days with the same variable. Let me show you what I mean. So if I just run this, let me just run this. So when I run that and I open it up, I now have a variable called week, and it gives me the date of the start of that week. Okay. So there is a way to use epi weeks where instead of seeing a date, it would give me a 1 to 52 number corresponding with that week. So you'll notice I have January 2nd and it goes for 7 days, right? That tells me that all these dates started on the week of January 2nd. So let me get rid of that now. My next line here, line 72, the group by function. This is very important when you're doing calculations because this is going to group things together. So if I wanted to calculate all total cases for the specific countries, I have to group all the data together for each specific country. I do that by the group by function. So in this one, I'm grouping by location and then week. So what it's saying to RStudio is first group everything that has Canada in location with Canada, the same for Sweden, Denmark, Chad, and United States. It's going to kind of coalesce all those data into the proper bins. Then it's going to look at it and it's going to do the same thing, but for week. So everything that starts in the same week or that's the same in that variable, it's going to bring them together and say this is all associated. It does this in hierarchical fashion. So it's going to start with location, and then within location, it's going to do it again in week, and so on and so forth. Okay, so I could realistically do it by country, then by city, and then by week, or so on and so forth. Then I'm going to use tally. Tally is going to count everything in the groups that I've distinguished. So if I run just this, you'll notice my variables also went down. When I tally things, it's going to leave the location, the week, and then it's going to give me a new variable, which I'll show you here, called N. And N is just the totals based on the group. So it's grouped everything by Canada first, then by week, and then it gives me the totals for the counts, right? And that total is the values from new cases, which I've specified. The last line, I am just renaming to weekly cases so that I know what the N value is. If I run this again, you'll see that what was once called N is now called weekly cases. And because I can't use a space, it'll error, I have an underscore. For me, that's just easier than using the dash. That's, to be completely honest, it's a bit of laziness, but it's also a bit of how I've always kind of been taught RStudio. So I just stick with the underscores. Okay, so we have our totals. Theoretically, I can now use this. I can even just copy paste, but I'd also have to kind of merge my data set again with population and do the incidence. Okay, so I would follow the same process. I'm not going to do it here because we've already kind of calculated incidence up here, but I can now go back and do it again for the weekly cases. It's the same process, right? Because I have my counts now. Okay, so now that we've done that, let's look at calculating averages. Okay, so yes, okay. So we're going to talk about just kind of the normal average, first of all. And then I'll talk about the rolling 7-day moving average. Okay. So the first one, let's say I want to know the average number of cases in a specific week, or kind of plot it that way. All I'm going to do is I'm going to follow the same sort of thing I did for getting the total, right? I bring in my data, I filter the dates I want. I'm going to create a new variable for the week. I group by location and the week. And then this time, instead of tallying, I'm going to use mutate, and I'm going to use this command mean. And what mean is going to do is it's going to give me the mean value of everything that's been grouped together. So in this case, a week. So it's not magically looking back a week's time. I've distinguished that I want to look at this time period. I could change this to month, and it would give me the new monthly average, right? So let's do this first, and then maybe I'll change it to monthly just to demonstrate. So if I run all this, oh, I've also rounded here, and I round to get rid of the decimal place because I haven't distinguished what I want to round to. So I go to OID mean, pull it up. And so now this gives me the weekly average. So you'll notice with tally kind of did this nice thing where it eliminated all the dates and I only had the week. You'll see here I have a redundant value for the weeks. So it's just something to be aware of, especially when you go to make a graph. It's not going to look so nice because you have this redundancy. Okay, so again, just something to keep in mind. There is a way that you can eliminate this to get what you need. But we'll do that in another kind of tutorial if need be, if we have time. Okay, so that's my weekly average. Okay. Now what I can do is I can bring in my population data. I can merge the two together, and then I can calculate the incidence based on that weekly average. Okay, pop it open, and weekly incidents. Or I should say, realistically, what we just calculated was the average daily incidents. We just did it a different way. Okay, so that's one way to get an average over a specific amount of time, right? If I don't group by week, if I took out the week part, it would just give me the average of Canada, United States, Sweden, Denmark, so on and so forth. Okay. Now, there's something called the 7-day moving average. What this does is it gives us a good read at the previous trends that have been going on, and it also does it in a manner that it kind of eliminates the outliers. Typically, how I've used it in the past is I've used a bar graph to look at the actual incidents, um, and then I've used kind of the 7-day moving average to kind of smooth out that data. Okay, so um, if I just use like the daily incidents, maybe I'll show you. I'll swap it out here in a second when I get to the graph portion. But if I just use daily incidents, it gets very choppy. It doesn't really portray good information, just because you can have outlier weeks or days. I should say more so with the days, where the graph is just all over the place. If I use 7-day moving average data, it kind of smooths it out so I can get a better read of the trend that's going on, right? One erratic day, yes, it will bring it up. However, it won't be very choppy when I look at a large amount of data. So that's kind of one way that we calculate it. To do this, I use a command called sequence data. The first thing it's going to do, this sequence data from the tidyr package, is it's going to look at the dates between the minimum date in my data set and the maximum date. In our case, it corresponds with January 1st and December 31st. And it's going to look through the entire data frame, and it's going to make sure that there's no missing days. Okay, because that's going to mess up the rolling average. If there's missing days, it'll either, depending on how friendly your data set's being, it'll either error, or what'll happen is you'll just have a big gap where that data should be. So once I run that, I'll have zeros where there's actually no data. And then I can calculate the incidence as we've already discussed. I'm going to round it to 2 decimal figures. And then what I do is I group it by location, because that's kind of like when we looked at the weekly totals and the average. I want to group everything together that's related. So in this case, I'm going to look at all the Canadian data, and it's going to perform, RStudio is going to perform this function independently for Canada, then independently for the US, Denmark, Sweden, Chad, so on and so forth. Now this code, it's a nifty little function called the slide index double. I do believe that it walks through this in the EPR handbook, so it'd be good to kind of refer to that. The only thing worth noting is when you get to this days for the rolling average, right? Because it doesn't have to be a 7-day rolling average. I could do 14 days, I could do 30 days. But when I put in the number of days here, it's always 1 minus what I'm looking for. So in this case, I'm looking for 7. 7 minus 1 is 6. That's because it's saying take the day that you're using and the 6 days before it, right? So it would equal 7. And then I just rounded the data. So I'll run this. Now I'll look at that data set, and I get my rounded 7-day moving average, right? What you'll notice, and this first one is a good indication, because if I look at my, what's it called? My weekly, right? If I look at the first entry, I only have 1 day from this week. It's telling me that the average was 87 for the incidents. Well, I get 87.47 for that, so pretty close. If I then go to my instance here, same sort of thing. The daily instance, 87.7. I have 79.45 for January 2nd. Let me do this. So I get 83.46, which will be the average of the first and the second, and then so on and so forth, right? So it's going to give me a nice indicator of where it's going. Now, the actual data, it can be below or above, but again, like I said, visually, and this is what the 7-day moving average is for, it's for looking at something visually and identifying the trend, because our brains, it can get a little bit scattered if you don't use 7-day moving average. I think I'll show you a different example from other code that I've used, just to kind of give you a good visual of it. Okay, so that's really the code that I wanted to go over. But what we're going to talk about, and I'll talk about this in another tutorial, just because I realize I'm droning on about RStudio code. And so for those of you still with me, this is kind of the output I would give if it was something that was asked for me in a work setting. So again, I would probably be given specific colors to use, or I might be given different formatting. You can change the line type, so I can use dashed lines. I can use a whole bunch of different ways to display the data. I've done a little bit of extra to this plot. So for example, how it normally comes out isn't like this. I've coded for it, but as you can see, it gives a nice visual. I can compare kind of what's going on based on the 7-day moving average of cases. So if we look, Canada way down at the bottom, looking pretty good. When we compare it to Sweden, eventually, also remember they were the ones that had the best strategy. You see a big spike. It does then even off, right? So we can make comparisons all the way through. And then of course we see United States kind of end up hovering above the rest. But then at the end, we all kind of even out. Now, what I should have added here was a gray bar that says data is still accumulating, because this data will eventually change as more data comes in. There's usually a 14-day lag between data entry and usability, let's say. Okay, so if I didn't kind of add extras to this, I'm just going to take the theme stuff out so you can see the difference. So I took away the grids behind it. If I just run the graph itself, this is what it's going to look like. Right, it's going to set the colors for me. It's going to set the date, how it looks for me. It's going to use variable names. So that's all stuff that you can kind of add in yourself. Like I said, we'll go over this in another tutorial just to get the finer points of graphing. Now I'm going to turn to a different project just because I want to show you what kind of things look like when you don't use 7-day moving averages, or if you don't clean your data or you have a pretty poor data set. So this is, it's a fitness coding that I've used, basically just looking at biometric data. And I did this kind of as a bit of an exercise from some standard data that I got, just to kind of practice and play around. So I'm not going to go through what I did, but it's basically, it's a bunch of heart rate data, step data, some fitness stuff for specific sessions, but just going through it quickly. Now, the one I'm looking for, I believe, is this one. Yes. Okay. So as you can imagine, now let me change this a little bit. Okay. So this is taking 7-day moving average and comparing it against the daily norm. Okay, so it gives you can kind of see the outliers is what I'm getting at in the way I've arranged it. Now, this is one of those times where it might make sense to show the daily unadjusted numbers, because you can see the outliers. In this case, it was looking for, okay, was there a spike in the heart rate So for example, if there's a spike in the heart rate, the client might be sick. And so that kind of tells us why there's certain days that, maybe we don't want to train that day. Maybe we do want to train that day. I should say I was playing around with data to develop it more so for a personal training application. This is actually my own data that I was playing around with. And then it was going to be in use of other situations. But if it was someone else's data, I probably wouldn't have shown you this example. I just wanted to make that a point. Okay. So let me change this from column to a line. And then I'm going to rerun it. Change this to size. I'll show you how hectic it can get. Okay, so let me actually take out this. Okay, so you can see that if I just look at this, there might be usability to it. Overall, it's not really visually pleasing, right? This might be something that as a researcher I would want to see. But if I was designing something to give to a client, let's say this was for either an athlete or clientele that was interested in their heart rate, or a stakeholder, I wouldn't give this to them just because what information are they going to gather? They're probably going to freak out about this dip over here. They're probably going to freak out about random spikes, right? And realistically, unless you're very familiar with the data or familiar with the subject, you know that heart rate is going to go up and down. You typically don't have a very steady line of a heart rate from day to day, right? It's going to vary. So we want to kind of reduce the burden on the clientele as best as possible, right? Like I said, to make decisions, that's one thing. If this was something to do with like an internal team, I would probably look at this as well. Or I would overlay it like I did with the bar graph and the 7-day moving average. Typically, though, what am I going to do? I'm going to show a nice 7-day moving average because I can look at where we've been, where it's kind of going, and this looks a little bit nicer, right? It's not always going to be perfect. Like I said, you still do get the peaks, but you can kind of see, I would more so be worried about this overall, oops, I just grabbed the whole thing, this overall spike and wonder, okay, what's going on there in the client's life to cause that big of a spike? Maybe they had the flu. Who knows? It looks like there were 2 subsequent events that caused either stress, or it could have been like a sporting event. If we're working with athletes, think about like something like the CrossFit Games. That goes on over the course of, I think that one's like 3 or 4 days plus recovery. You might have elevated heart rate for a specific amount of time, right? So those are a little bit more explainable than kind of big peaks and valleys that you have to go through each individual one, right? Okay, so that's basically it for the first RStudio tutorial. Again, very fundamental stuff. I understand that it can be overwhelming right now, but what I would suggest is, like I said, play around with it. That's what I did with that fitness data. I just took data literally off of my smartwatch and just started coding stuff just to see what I can calculate, what I can display. Is there anything usable out of that information? How can I alter the data? It was just a good way to practice without, having to look at different data sets. Or in that case, I was looking at infectious disease data a lot. I wanted to look at different kind of data. But find a data set, play around with it, use the EPIR handbook and Stacked Overflow to kind of go back and forth. And yeah, if you have any questions, please don't hesitate to ask. I do know this stuff can get pretty confusing, but there's always an answer or a workaround. That's the best part about coding. And yeah, just have fun with it. So we'll see you in class.